It's 1893, and the polar explorer Fridtjof Nansen is navigating in a fjord in northern Siberia. His boat is traveling at 6 knots, but suddenly it slows down. Nansen is baffled. The wind hasn't changed, yet an invisible force seems to be holding his boat back. How is this possible? Let's dive in. Fjords are often surrounded by snow-covered mountains. When the snow melts, it creates a thin layer of fresh water that is less dense than the salt water beneath it. This fresh water forms a distinct layer that floats atop the denser salt water. Oceanographers refer to this phenomenon as stratification, when the ocean separates into distinct density layers. The stronger the layering, the more pronounced the stratification. Even a thin, freshwater layer can significantly slow down a ship by generating invisible internal waves at the boundary with salt water. As a boat moves through stratified water, it generates not only surface waves, but also invisible waves at the boundaries between freshwater and saltwater layers. These waves drain energy from the ship, as it must push both surface water and the boundary layer, creating a drag force that hinders forward motion. While modern motorized ships are usually fast enough to overcome this effect, in the past, this phenomenon called dead water could have had significant consequences. Take the Battle of Actium. In this pivotal naval clash, Octavian, the future Augustus Caesar, faced off against the combined fleets of Mark Antony and Cleopatra VII. Their defeat marked the end of Egypt's dominance and the rise of the Roman Empire. Ancient rumors blamed Antony and Cleopatra's loss on remoras, suckerfish said to have attached themselves to Egyptian ships, slowing them down. But there's a more plausible explanation: dead water. The battle took place in a shallow area between the Ionian Sea and the Ambracian Gulf, one of the few parts of the Mediterranean where salinity stratification occurs. This could have slowed down the Egyptian ships, preventing them from reaching ramming speed and giving Octavian the advantage. Thank you so much for watching. If you made it this far, I know you're as passionate about learning as I am. Be sure to check out this video on the secret underwater tool the Navy used during World War II. Thanks again, and see you next time.